So now we're on to the digital data acquisition section of Lab 1. So as I mentioned before, this splitter, one end of the BNC cable is going to the oscilloscope and the other is actually going to this DAQ. So this is a measurement computing DAQ, and so it can measure all sorts of ports. We're really only going to use channel 0. I'll zoom in on those in a little bit. But basically how they're connected is the BNC cable right here goes all the way around and actually ends up splitting into a red and a black cable, which can then be connected through little clamps. If you can see this can clamp on, and it can clamp and onto jumper cables, which then go into these little ports. So if we take a close-up look at this, and hopefully it can auto adjust. If not, I'll have to do it manually. Okay, so how this works is, for instance, for this port right here, if you use a screwdriver, you can actually screw this up and down. If you look at the internals, you can actually see that little bar moving up and down. So how that bar works is essentially it will clamp onto one end of the jumper cable. We are going to use channel 0 high for the red signal and channel 0 low for the low signal. It doesn't technically have to be ground. We typically use it as ground because there are grounds in our other equipment. So we have a ground in the function generator. If we were using the breadboard, we ground that. So you don't actually want to have another ground. So if you hooked it up to this one, you'd have some problems. So you always want to make sure that you're using channel 0 high and channel 0 low. Again, you can screw that up and down and run it. So how this works, so if I have MATLAB open on this computer, it is connected to the computer through this port. This goes directly to a USB that's plugged into the computer up here. So I'm going to run MATLAB on it, and so when I click run for the file that we have downloaded, it's just titled USB 1608G sample. So first of all, I'm just going to click run, and you're going to see it's not measuring actually until this part actually starts blinking. Right, so after waiting for the DAQ to start blinking, looking at the computer screen, the code will pop up this picture. So what we actually want is 1 to 2 full periods of a sine wave. So this is too much. It's also not super smooth. We could take a little bit more data for that. So what we're going to try doing is we're going to adjust the sampling rate. So if we adjust the sampling rate to 1,000 and we run it again, it'll take a second to pop up. And actually, so that went the wrong way. See, so it got even worse. So you generally, if you want to get a smoother curve, you want to sample faster. So let's actually go really far in the opposite direction and actually just sample way faster. And we're going to run that. So here we have a pretty smooth looking sine wave, but the problem is we only have, well, I guess we almost have a full period, but we really want 1 to 2. 2 is probably more preferable, so you can kind of get the general shape if you were looking at it. So in order to increase this looks like we're sampling fast enough. So the sampling rate is essentially adjusting the distance between these times, right? So the faster the sampling rate, the less distance there is between these points. So what we can do is we can adjust the number of samples. Again, that was roughly 1 period, a little bit less. So if we double the number of samples and hit run, we can end up with about 2 full periods of the sine wave. So that looks pretty good. So now what we're going to do is analyze this data. So in order to analyze this data, it will have saved it in the MATLAB directory as sample data. You actually could change that if you wanted to, but there's no real reason to. So we can exit out of this, right click on sample data.xls and click open outside MATLAB. It'll load the Excel document. For some reason, the DAQs give channel 0 and channel 1 data. You only really sampled with channel 0, so we can just delete channel 1. And this is the data that you can find on Canvas. Use this data to make the plot that we request in the lab. So at this point, I'm going to leave everything, the rest of it up to you guys. But basically, I showed you how we got the data, and I showed you how to open it and how we opened it. So just create the plot. Should be roughly the same as the MATLAB plot it showed. But of course, you're going to have to make sure you're following all the formatting guidelines and make sure everything looks good. All right, that is the end of this one. So thank you very much and have a good day.